The past 2 weeks of my life have revolved around two things. First, physical geography, whether it be lectures, essays, or this textbook, which feels like it could do some damage if you dropped it, and the Mars 2020 mission in which NASA successfully landed the Perseverance Rover on Mars, and oh my god, it was a glorious sight to see. Now, I actually watched this alongside the community in Tom Carroll's Discord server, which I've been helping to set up, from which I know a few people have popped over here from, so sup, welcome, glad to have you here. But since the landing itself, we've all been chatting about the mission, talking about the landing video which came out, and sharing a lot of the photos which have come out since. Now, one photo in particular caught my attention. With my head full of geography landforms from a lecture I just had, this photo got shared. And I thought to myself, that's a really nice view of the horizon with all those hills. Why are there hills? So I did some digging. I learned about the geography of the landing site. I got called a geography nerd by another nerd, which I'm not sure whether that constitutes an expert opinion or whether that cancels out the comment entirely. Either way I can take it. I threw together a graphic to show some other nerds what I'd found out, and oh, it's so cool! The graphic design is horrible, but the content! The content is so cool. I don't think I've ever had so much of an appreciation for the adage that a picture is worth 1,000 words, because I could genuinely talk for hours about this. Now, weirdly enough, I've not been able to find the source of the photo which was posted in Discord, and neither has anyone in the comment section of the Reddit post, which I tracked the photo back as far to. So for the sake of this video, I'm going to substitute it with this 360-degree panoramic photo from NASA instead, because we know it's definitely from the rover, and it felt weird not having a source for this photo, so I'm going to instead use this one. Now, the fact that we have a 360-degree panoramic photo taken from the surface of another planet is insane. But today at least I'm going to leave explaining the actual aspects of the rover to the people who know what they're talking about, rather than me just gaping over every single detail despite not being able to explain any of them very well. I chose to study geography rather than engineering, and so I'm going to stay in my lane, even if that choice was actually a really close call, which I had been planning on talking about for this week's video, but that can wait because Martian geography is so freaking cool! On to business. Let's talk about landforms. Landforms are relics, meaning that they are the outcome of processes of the past. What we see now is the outcome of past processes. This is a key thing to remember. Now, we've got a lot of examples of this here on Earth, especially anywhere that ice or water has been and then vacated. Ice and water is just messy and shove stuff around to no end. It's the landforms that they leave behind today that enable us to learn about what's happened in the past. That's why we know about past glacial periods here on Earth, because there are a number of cirques, U-shaped valleys, and drumlins, and a number of other landforms just scattered about from anywhere pretty much that glacier and ice sheets have covered over the past million years. Of course, the ice isn't there now, but we know that at some point in history, ice was previously in these places because of the landforms that the ice created have stuck around since. It's a very similar case with fluvial or just water and river-based landforms as well. You can get oxbow lakes, you can get spurs, and particularly you can get valleys as well, like this valley or this valley or this valley that's on Mars. I'll leave a link in the description to an article and accompanying video by NASA, which I think explains this better than I can, but to summarize and also smush together some of their graphics to make it easier to visualize, the landing site of the Perseverance Rover is a lake bed, and part of the reason that we know this is because there is a delta and a valley spilling into that delta. These are landforms we are seeing now, but they are a result of processes in the past, particularly there being rivers in the past. The river would have been flowing through that valley and accumulating and taking with it lots of sediment, which is just dirt that the river carries along. It comes in a few different types, I'm not going to go into that. But as the river meets the lake, the water slows down and loses a lot of its ability to carry sediment. And so it drops it, and so that's what's formed the delta, the big, weird-looking deposition area of dirt, of sediment, because the river has lost its ability to carry it. So literally as I'm editing this, NASA are about to go live and talk about the Perseverance landing site, and I get the impression that they're literally about to talk about all the stuff which I'm so excited for. Now, for a bit of context of why I'm about to get really excited during this live stream that I was watching, let me explain what I actually did when I did all that geography research for the guys in Discord. I saw the photo and recognised the landform of the valley, and then went and researched and found the animation which I smushed together and just showed you, which demonstrated that there was a delta. but I of course had no idea what angle the photo I was seeing was. This could be just two hills on from anywhere around the rover, from any part of the lake. What I was really proud of though is the fact that I managed to spot the ridge of the delta.
The near ridge closest to us is the front edge of the delta, the Jezero Crater Delta.
I was right!
It brought us to this site. It brought this rover to this place.
I was right! I was right about the delta and the mountains and the valley, and oh, that's so gratifying. Because I recognised this in the photo. Or at least I recognised the mountains and the valley in the photo, and then matched up the delta after looking into a little bit more about the crater, and oh, that's so gratifying to know I was right. Oh, that's so gratifying. That's so cool that I saw the photo and was able to interpret for myself, and I'm now getting that confirmed as being right. It's really cool. I think, and they're literally about to go on to talk. I'm watching it live, but I've paused it for a little bit. But they're about to go on to the fact that they've got a few things within the 360 panoramic photo that they've picked out of being of interest, and they've just seen from the photo itself, which I think proves my point, is that there is so much that you can learn from a photo and so much to study from it. I, as a geography student, was able to spot the edge of the delta and understand what that was, what I was actually looking at within the photo, and able to explain it to others. But there are people who know a hell of a lot more about these kind of landforms than I do, who are also poring over these photos, and it's through their work that we're going to learn a whole lot. This is what I mean about the fact that they've got some of the best scientists looking at it, because they spotted smaller things like this, which I hadn't clocked yet. Albeit because I wasn't actually looking at the panoramic photo. You know, when I was talking to the Discord guys, I was looking at the other one. But this is what I mean. They have good people who are clocking stuff like this rock. Like this really resistant rock that might have been part of the delta that they're going to get super close to. Oh, it's just so cool. There's so much to be learned. What's just super exciting for me is the fact that I, as a second year geography student who vaguely knew what to look for, was able to look at these photos and recognise the processes, put them together with a couple of different angles from both the animation and the photos as well, and recognise and imagine what that was like as an area to be in before, what that lake, what that river was like. And it's just really cool. We were discussing this in the Discord, and it's really weird to imagine Mars with water, just the sort of blue and red muddy that it would have been mixed. Someone in fact pointed out that quite often when we think of rivers, we think of kind of the greenery that's lining it. You can actually Google, and there's maybe a few illustrations here or there of what Mars might have looked like with water. But yeah, it's weird to think about. But this does remind me that people sometimes see this generation as born too late to explore the world and born too early to explore the universe. This feels like the frontier of exploring the universe is commencing. It maybe not commencing because of the moon landings, but it feels like we're getting closer and closer to just having a huge amount more to look at. We're just going to learn so much about Mars as a new frontier, about its history, about what it looked like before, and perhaps what it could look like with a lot of terraforming. It's just so cool. There's so much that we're going to learn as just another discipline that can take advantage of what the Mars Perseverance Rover is looking at. I mean, it's gone to look for signs of life. That's why it's gone to a lake bed, because sediments of lakes are really good at holding information and keeping a great record, and so you can drill down into those, get samples. If there's anywhere that's a good candidate to look for signs of past life, then that's one of the places to go. But even just all of the other offshoots of information that we're gonna get, we're gonna learn so much. It's so cool. I know this video is just me nerding out, but hopefully it's gotten you curious a little bit. I hope if you didn't know before, you now understand why a lot of people are curious and really interested, and why this rover is such a big deal. Space is cool, I think geography is cool. If you're watching this video, then hopefully I've converted you to think that space geography, Martian geography is cool as well. If you want to be further converted to thinking that geography is cool, then subscribe to this channel. I'm a geography student into productivity, renewables, sustainability, all manner of things. This video I'm filming it like a couple of days before it comes out, because it's just come up and it's just cool. I want to talk about it and get other people to at least sort of hop onto it. And so I'll leave that article that I talked about in the description. You can follow me on Twitter there as well, at TristanLSharman. I've been rambling for about half an hour at this point, so I have no idea what this end product of the video is going to look like. But hopefully you've enjoyed it, hopefully you've learned something. If you have, then leave a like, and if you have really enjoyed it and want to see some more videos like this, or maybe videos like this that just have just a dash more structure, just a little bit,
then feel free to subscribe, it would really help me out. But until next time, enjoy the spiral of Martian geography which I have probably just set you on, and I will see you in the next video.